Hello, my name is Kurosh Sadrov. I'm the Senior Director of Product Management at Fortinet. Today I'm going to give you a demo of Fortinet's wireless LAN solutions and our new features. But before we jump into the demo, I'd like to give you an overview of Fortinet and our approach to secure wireless. Fortinet was founded in 2000 to create the industry's first Universal Threat Management or UTM solutions. The company successfully went public in 2009 and currently has over 100,000 customers. At Fortinet, since we have developed application-based quality of service that's in use in our UTM security appliances, we can easily apply this deep inspection technology to the wireless medium, and that's actually one of the big differentiators to use our wireless solution. Fortinet entered the wireless market in 2008 with the FortiWi-Fi product family. The FortiWi-Fi is a thick access point that provides coverage to about 300 square meters or 3,000 square feet, ideal for the distributed retail or remote office applications. For larger installations, we have a FortiAP product family. This is a thin access point architecture and works with the FortiGate product family as its wireless controller. This is the FortiWi-Fi 60C, a member of the FortiWi-Fi thick access point family. The FortiWi-Fi 60C provides full UTM functionality and embedded 802.11 ABGN access points, providing up to 300 megabits per second of bandwidth. This is our thin access point product. This is our FortiAP 220B, a member of our FortiAP thin access point product family. Our outdoor access point is called the FortiAP 222B. This access point provides dual radios for both 2.4 and 5 gigahertz frequencies and maximum output power of 500 milliwatts or 27 dB. This product is ideal for installation in golf courses, resorts, and industrial yards and other challenging environments. The FortiAP 220B has a unique feature that provides simultaneous Rogue AP scanning while the other radio provides client access. This is achieved by a special hardware design unique to Fortinet that allows Radio 1 to scan both channels 2.4 and 5 gigahertz, while the other radio can be dedicated for client access. Using this approach, we can ensure that the dedicated radio can detect, monitor, and suppress rogue APs full-time without having to do this in background scan mode. This saves you cost by not having to deploy an extra air monitor in the same areas that you have access points. For ease of installation, Fortinet access points can be powered through Power over Ethernet PoE injectors. This eliminates the cost of running an AC power outlet close to your AP and greatly reduces deployment complexity. For this purpose, Fortinet provides the GPI 115 Power over Ethernet injectors. Fortinet provides the largest selection of wireless controllers in the industry. This allows you to right-size the number of access points for each installation to reduce the total cost of ownership. The controller family can scale from single-digit to thousands of APs in a single installation. Since most FortiGates can be software upgraded to become a wireless controller, this eliminates the need for you to purchase a separate wireless controller. In most circumstances, this provides you a one-third savings over alternate solutions. FortiGates consolidate multiple devices into a single appliance, including the wireless LAN controller. For this reason, most customers decide to deploy the FortiGates in a high availability fashion. In this mode, the FortiAP seeks out all available FortiGates on the network and connects to the first one that it finds on the list. If that FortiGate fails, then the FortiAP seeks out the next FortiGate that's on its list to maintain network availability and performance. This is the end of the overview section. Now let's get started with the demo. To showcase the integration of the wireless controller in the FortiOS, I'd like to take you through the management GUI and to show you a few key points. This is the management interface, and we see that the management dashboard is currently displayed. The wireless controller is a tab in the same familiar user interface that IT is used to. In this management interface for the wireless, we can see the FortiAPs that have been discovered on the network. In this case, I have one FortiAP that's connected. The other one is disconnected onto the network. You can see the model numbers, the serial numbers, and where they're connecting from, and even which channels are being used on the FortiAP. The important point that I wanted to point out here is that we have a central profile-based management. With this, you can create a profile that can apply to all physical APs in your enterprise. So by making a single change in this interface, it can propagate to all the different physical access points that may be distributed across the campus. In this interface, you can set the mode, whether it's a dedicated monitor mode, just like we saw in the 40AP220B. It can also operate on different bands, so you can pick a 2.4 gigahertz 802.11n or the 5 gigahertz version of the 802.11n. You can turn on the short guard interval or the wider 40 megahertz channel width to get higher bandwidth. And this is also the user interface that allows you to direct the radio provisioning engine to pick between the select channels that you would want to have, you would like to use on the wireless network. Transmission power and SSIDs are also selected here. These custom profiles can be assigned to the wireless 40 APs, and by a single click, you can propagate this change to all of the access points. The other thing I wanted to point out here is that each SSID that we have configured provides the capability to set the IP address range, the mask, and the different authentication options. So for instance, in this case, we have WPA, WPA2 personal, which uses a pre-shared key, or the enterprise version, which uses a backend authentication store that can be the Radius database or the local user database. Or you can even select the captive portal page for hotspot or hospitality situations. We also have features to block the intra-SSID traffic, as well as limit the number of clients that's on the network. Now, the key point that's noteworthy is that you see SSIDs here that are called employee, guest, and Wi-Fi AP. If we go under the system interface and look in there, this physical interfaces, we also see the same SSIDs displayed here as physical interfaces. And these are essentially virtual interfaces that are intermixed with the physical interfaces on the box. What this tight integration allows you to do is to use the same UTM features that people have been using for multiple years to protect the WAN-LAN boundary on the wireless network. So for instance, I can plug in, double-click on the employee interface and see the same IP addresses that I have configured. And in the firewall interface, I can also see that that I can set policies between the employee SSID and different zones, for instance, the WAN interface or the LAN interface, and apply all the UTM traffic shaping and email security protections that the UTM offers on the same traffic. Finally, let's talk about some deployment options. FortiGates deployed as gateway devices can be used as wireless controllers. The FortiAP seeks out the FortiGate controller and creates a CAPWAP tunnel to these FortiGate devices that are deployed as the gateways. When a client connects to the FortiAP, its traffic is tunneled through this CAPWAP interface to the FortiGate controller before it's routed to its final destination. So in this example, we see that a local printing takes place by the FortiGate forwarding the packet to the printer, or the remote server across the cloud can also be accessed in this deployment fashion. The other option of deployment is to deploy the FortiGate in the wire closet, and this is suitable for larger deployments where the FortiGate at the gateway may not be sized at the highest capacity that's required for the LAN traffic. So in this fashion, all the FortiAPs seek out the wireless controller in the closet, and all the traffic is tunneled to this first FortiGate and then enters the LAN at that point after it undergoes the security processing. Another option is to use the FortiGate in the data center as the wireless LAN controller. And again, all the FortiAPs, since they're able to connect over layer 3 IP networks, they can seek out the FortiGate in the data center, after which point the traffic gets secured and then it re-enters the LAN to get to its destination. In both deployment modes, the FortiGate's telemetry is collected by the FortiAnalyzer, and the FortiManager central device provides global management for all the FortiGate appliances, which in turn control the FortiAP devices. An essential part of a wireless deployment is the planning stage to determine the number of APs that you need and their coverage for your floor plan. For this purpose, we've created a tool called the FortiPlanner that's customized for the FortiAP product family. I will be demonstrating this tool later in this presentation, but if you would like your own copy, please go to wireless.fortinet.com for download information. In this section, I'd like to demonstrate the dynamic radio resource provisioning algorithm that's built into the FortiGate controller. For this demonstration, I have a Fortinet access point that's connected to the FortiGate controller, and I also have an access point that's going to act as the interfering device. It could be your neighbor's access points. I also have a client PC that will demonstrate the channel allocation. I have a channel sniffer on this laptop, and I also have my management interface. To show you the demo, we're going to allow the FortiAP to select its own channel dynamically. In this case, it has selected channel 165. Then we're going to introduce the interference source, and as you will see on the wireless sniffer, the interference source will also occupy the same channel and will start interfering with our FortiAP access point. The FortiAP access point, after a few minutes, will sense that this channel is non-optimal, and it will then select a new channel based on the FortiGate configuration. And in this demonstration, we see that it's going to select channel 149 and occupy this new channel. When this happens, essentially the clients move seamlessly to this new channel, so the connections are not dropped. And since the channel is also a free channel, the communication returns back to its optimum state. The radio resource provisioning can be configured in the management system under the custom AP profile. Over here, you will see that channels 36 to 165 are selected, telling the AP that any of these channels can be used in the calculation for the AARP algorithm in case another optimum channel is needed. In this case, I can unselect certain channels if I don't want the AP to use them. For our demo, we will keep all of them selected so the maximum number of channels can be used. Now let's switch over to the Air Monitor PC. We see that the FortiAP is shown in the yellow solid line, and the interfering AP is shown in the dotted yellow line, and they're both occupying channel 165. At this moment, the FortiAP is looking for other available channels, and because it detects that there is an interfering AP occupying the same channel. And now you see that the AP, the solid yellow line, has moved to channel 149, and it has avoided the co-channel interference, and it has taken all the clients along with it. So this is an automatic process, and it's as part of the radio resource provisioning that's built into every FortiGate wireless controller. Now I'm going to show you how we support client mobility through fast roaming. Because the authentication process to an AP usually takes several seconds, technology has been developed for pre-authentication and key caching. The way that this works is that when a client is associated to an AP and it's downloading content, so in this case we are going to show you a video download. This client, when it's moving, it may get further and further away from the AP that it's connected to, and it may see another access point that's within reach, that has much more powerful signal level that it should connect to. In this condition, the client will actually perform a pre-authentication to this next AP through the AP that it's already connected to. So in this case, it's actually going to pre-authenticate and pull the authentication keys for the FortiAP number 2 through the wireless controller and through FortiAP number 1 back to the client. So now the client has the keys so that it can quickly associate to the next AP without having to go through the full cycle of authentication. And the video stream is not interrupted, and the client can continue watching the presentation or carrying on the audio conversation. So to demonstrate fast roaming, we're going to use 2 access points that we have here on the table, and we're going to simulate a movement of the client by reducing the power of one of the access points so that the client thinks that it has moved away from the access point, and it's going to join the next powerful access point that it sees. So on the management system, you see that FAP1 and FAP2 are the name of the access points, and we have one client that's joined to access point 1. I'm going to go to the next screen that's going to allow me to reduce the power of the access point 1 So I'm going to reduce the power from 100% down to 7%. And at this point, the client is going to notice that the power, that this AP has gone away. And as you notice, at this point, the client is going to connect to the next access point, as you see in the GUI, and the video continues to be uninterrupted. So now you see that there is a client connected to access point 2. And on the video screen, you didn't see any frames drop or any issues with the communication, and the session remains active. Now let's take a look at our guest access solution. Fortinet provides guest access through a captive portal screen, and this is a browser page that intercepts all wireless communication and instructs the user to log in to the FortiGate wireless controller. We are able to authenticate guests to a different directory store to isolate them from the Active Directory or the employee authentication, so that we provide a level of isolation between the two directories. We are also able to isolate the guest access traffic from the LAN traffic. And on the back end, we also support third-party billing solutions. Also, when a guest is logged in, we can protect the network by our UTM security appliance by scanning the guest traffic to ensure that they're not sending spam mail to potentially affect the reputation of the IP address of the company or the resort that the user may be visiting. And we also separate the two or multiple clients that are sharing the same hotspot so they actually don't see each other. So we call this the intra-SSID privacy feature, which is very useful in the shared environments. And finally, the captive portal screen is two-factor authentication enabled. So for strong authentication, for instance, the employee SSID, the captive portal screen will pop up an extra two-factor authentication token page, and I will demonstrate this next. So for this demo, I'm going to set up a guest SSID that's configured to authenticate users using the captive portal screen. So now we see that the configuration screen actually has an option for captive portal. I can also select what user group the guest should be connected to. So I have configured a separate isolated directory for guest users to be authenticated against. And as we saw before, the guest SSID forms its own interface in the management GUI. So if you go under System Network Interface, we see that there is actually an extra guest interface. This is a virtual AP that has been added in as a virtual interface. And this AP is now available under our policy settings. So I've set up a policy from guest to WAN 1 that allows all the traffic, but I'm going to actually go in and turn on our UTM security features on this traffic to allow us to observe and ensure that the guest users are not entering the LAN traffic, but also they're not sending email, spam. We can also enable IPS features, so in case the guest user laptops are infected, they don't infect the rest of the network or other users. And I'm going to press OK on this. I'm going to go back to the SSID for guests, and this extra feature that we've introduced to block the intra-SSID traffic also ensures that two guest users cannot interfere with each other, and their traffic is completely isolated, and they can only communicate to the internet. Now we're going to switch over to the client here, and on the client, I'm going to join this new guest SSID that I just created. So we see in the Windows wireless configuration interface, I'm going to find the guest SSID, and as Windows is connecting to it, it's going to it's connected, but then it's going to actually pop a box that says additional login information is required. And that's the end user's queue to open a browser. And their browser communication, it doesn't matter what websites they're going to, it will get intercepted by the Fortinet controller, and it will display a configurable captive portal page. So this page is HTML customizable. You can add your own logo to it. And you can have different captive portals for different SSIDs in our new 4.3 version. So in this particular demo, I've set up a guest account, guest1, with a password. And Next, it actually asks us to agree to a set of terms and conditions before we can use the network. So this page is also configurable for your needs. You can go in and basically put any legal terms in there. This page could also be used, for instance, for payment information. So if you want a user to be redirected to an external server to pay for hotspot access, or sign up, for instance, for an email marketing campaign before they're allowed to get free Wi-Fi access, you can do that in this page. And once I agree to the terms and conditions, then it's going to forward me to the page that I was trying to go to. Now, the other part of the capability that I wanted to demonstrate is the ability to support two-factor authentication. So this is used for employee access in many cases where you don't want just a username and password, but Fortinet also provides a FortiToken 200, which is a one-time password token. And when I connect to this employee SSID and I log in with my own Active Directory username and password, you see that it after successful login, it shows me a token screen. It says FortiToken code required. And that's where I need to actually look at my token and type in the numbers. So I'm going to actually do that right now. I have a token in my pocket which displays random 6-digit numbers. As I type this in, it's going to validate that, and it's going to allow me to log in to the network. So this is a two-factor authentication with the captive portal screen. So now let's demonstrate our Rogue AP control features. For this demonstration, I have the following setup. I have a FortiAP that's connected to the FortiGate controller, and I have a valid client that's connected to this FortiAP. And what we're going to do is we're going to introduce a Rogue AP that's going to be picked up by the Radio 1 that's doing air monitoring on both 2.4 and 5 gigahertz frequencies, while Radio 2 is continuously servicing the laptop without interfering with the Rogue AP detection radio. So the other thing that we're going to do is we're going to connect this Rogue AP directly to the Ethernet switch. And the reason that we are doing this is that you're going to see a difference between a Rogue AP that's connected to your network versus your neighbor's access points. And then finally, we're going to see that if a client connects to a Rogue AP and tries to, for instance, access any of your resources on your LAN, the FortiAP is going to detect this and allow you to send the authentication frames to both the AP and to the client to sever the connection. So let's set up the Rogue AP detection capability by going to the wireless controller tab and opening the custom AP profile and selecting a specific profile that's going to be used for our wireless access points. In this menu, you'll see that I've chosen a FortiAP 220B, which is the dual radio access point. And Radio 1 is the one that can scan both the 2.4 and 5 gigahertz frequencies. You'll see this in the drop-down menu that it shows both the 802.11n and 802.11n 5G frequencies. So I'm going to place this radio in a dedicated monitor mode, and I'm going to turn on the Rogue AP wireless on-wire scan. The second radio I'm going to just configure as an access point, and I could also enable this one to do background scan if needed. But since Radio 1 is a dual-band radio, I'm just going to disable the background scan and press OK. So now we're going to go to the monitor screen to see what APs are in the vicinity. In this screen, you will see a list of APs that have been scanned out of the air. So you see the channels that these APs are using, what is the security authentication type, the MAC address that they're using, and even the vendor ID of these rogue or neighboring devices, the signal strength, and which of one of our FortiAPs is picking up this activity. You will also see that there is a column called on-wire at the end, which shows that a particular AP is actually on the wireless LAN, whereas the rest of the APs that don't have this indicator are neighboring APs. So it could be an adjacent business, for instance, or a neighboring AP that is being picked up, but it's not a threat to the business because it's not physically connected to the network. So in this particular instance, I can accept this indication that this is on the wireless LAN and mark this manually as a rogue AP. And you will see now it will show up at the top as a rogue access point. Now I have the option to actually suppress this access point. The suppression, it basically prevents any client from connecting to this access point so that they cannot get through this AP to my wireless LAN. This is beneficial during the time that the IT operations team is trying to seek out this physical AP and remove it from the network to reduce any chance of data leakage. So under the suppress icon, I'm going to select that AP and press the suppress AP button, at which point any client that tries to connect to this will be suppressed. So I'm going to now switch to a client and demonstrate this feature for you. So I'm going to have a ping screen going on this client, and I'm going to connect to the rogue AP that has the SSID of interference AP. And I'm going to now turn on continuous ping, and you'll see that after I press the suppress button, instead of getting a reply back from the server, you see a hardware error screen show up. So this is an indication that even though the client is associated to that interfering AP, it actually can't pass any traffic, and it thinks that there is actually a problem with that link because of the interference that our AP is causing to remove this offending AP from the wire. Now, if you switch back to the rogue AP monitor screen, we're going to actually see this in the event logs. We can search for the rogue AP on wire event that you see in blue. It shows that the AP with the SSID of interference has been detected on wire and that the suppression is active. In this quality of service demo, I'd like to showcase the operational impact of our Layer 7 application-based quality of service. Since wireless is a shared medium, multiple applications from different clients can compete with each other for this limited wireless resource. So for instance, if somebody's watching a YouTube video and another person is performing a WebEx traffic and a third user is downloading email, all these three sources of information draw will compete with each other, and there is a strong possibility that the WebEx traffic can get impaired. The reason behind this is that these applications can take advantage of the wireless multimedia extensions that prioritize voice over video traffic, since they're either running in a browser or they're applications that are not aware of the wireless drivers that is running on that client. So for this reason, at Fortinet, we can use our Layer 7 based quality of service engine to be able to identify applications and then apply an additional traffic shaper on top of this to ensure that only business critical applications get favored higher than non-business critical applications. Now let's look at the user interface to set up the application-based prioritization for the wireless network. So on the graphical interface, let's go back to the Fortinet profile-based management and find the SSIDs that we are trying to apply the application-based prioritization. In this case, I'm going to apply the priorities to the employee SSID so that the employee traffic that is not business critical is prioritized lower. So to do this, I found the SSID for employee. I'm going to now go through the UTM engine and create an application sensor. The application sensor is essentially our way of creating and identifying what are the business critical applications. So in this case, I've created a category called business applications, and I've also added an application category called business. So Fortinet pre-categorizes applications as business applications or media, network services, peer-to-peer. There's a list of predefined applications. If you'd like to see what is in an application list, you can click on the full list button and see the full list of applications that we have signatures for. In this case, for business critical applications, you see that WebEx or Web Office is actually part of the list. So I can prioritize WebEx or MobileMe other types of real-time applications as business-critical applications. So now after configuring the application sensor, I'm going to go under the firewall and create a traffic shaper policy that is applied to these application filters. So under the traffic shaper, I'm going to create a business-critical category, and I'm going to assign it the different bandwidth levels. So for instance, for business critical applications, I'm going to ensure that all these applications get at least 50 megabits per second of traffic. So in this case, if the wireless is congested, we are sure that at least 50 megabits of the traffic is going to go to our business critical applications. Next, I'm going to apply this application-based traffic shaper to my wireless traffic. Recall that the SSID was called employee, so I'm going to find the employee to WAN 1 or employee to LAN policy, and I'm going to turn on the traffic shaping and also the application-based application control engine. I'm going to select this business applications. So with this particular policy configuration now, when I press I need to select the traffic shaper, so I'm going to click Business Critical Traffic Shaper. I'm going to turn on the shaper in the reverse direction as well, so both sides of the wireless traffic get the same policy applied, and I'm going to press OK. So at this point in real time now, the traffic shaper bandwidth limits are being enforced, and if there is any congestion on the wireless link that is not in a category that was in the business critical application list, that traffic will be prioritized less. And to demonstrate this, we're going to run a WebEx session in parallel to a video download. And since the video download is not in the application business critical application category, we're going to see that the video is going to suffer performance as the WebEx is going on. So to demonstrate this, I'm going to set up two PCs that are connected to the same access point. One PC is going to be running a YouTube video, and the other PC is going to be running a WebEx session. So on the first screen, that you're going to be seeing a YouTube video that's going to be running live, and it's going to be showing you a video. And on the other screen, you'll see that I'm going to start a WebEx session. So once this WebEx session is connecting and is started, you will see some motion and some videos going on in the WebEx that's actually going to take up bandwidth, and it's going to affect the YouTube video you'll see on the other screen, either right now pausing and breaking up. And this is because there is not enough bandwidth to actually run both of the traffic simultaneously. And this usually happens if the number of clients on an access point is above a certain number, or, for instance, if somebody is downloading a very large email file or an attachment, during that time, other clients or other applications will get affected since everything is equal. And the only way to be able to differentiate them is this layer 7 deep inspection that can identify the critical applications and slow down other applications so that the wireless clients that are business critical for you don't slow down. We recently announced FortiOS version 4.0 maintenance release 3, and with this we embed a full-featured wireless controller in every FortiGate platform without any additional software costs. FortiOS allows you to manage your wireless network using the same familiar user interface that allows your IT operations team to troubleshoot wireless and security issues quickly and apply policies uniformly to WAN, LAN, VPN, and now wireless, with the added advantage of reducing number of boxes, which leads to higher availability, increased business continuity, and the less number of support contracts that you have to maintain. Fortinet Wi-Fi solutions are built with world-class 802.11n chipsets, which provide 300 megabits per second of throughput per radio, giving you a total of 600 megabits per second of throughput on our dual radio access points. These access points are also backward compatible with ABG standards, and alternatively, they can be used as air monitors and simultaneous client access. Fortinet access points provide quality of service differentiation based on IEEE 802.11e wireless multimedia extensions. WME provides means of traffic differentiation, which is useful for voice and video roaming. In addition, for business-critical application, FortiOS can leverage its Layer 7 deep inspection technology to prioritize business-critical applications that can't take advantage of WME technology. This is a feature that's missing in other wireless offerings. Voice over wireless requires both security, mobility, while maintaining call quality. The support for wireless multimedia extensions meets the requirements for voice mobility by allowing the wireless handset to place its audio packets in the highest priority wireless queue. Also for mobility, we offer comprehensive fast roaming using forward key caching and pre-authentication across all the access points to avoid connection drops. As a result, any latency-sensitive application like voice can be supported without any quality degradation. The goal of the FortiGate Rogue AP Control engine is to meet the PCI DSS requirements by providing continuous monitoring, on-wire Rogue AP detection, and suppression. This is the standard part of the FortiOS wireless controller feature set and is provided free with no additional software costs. The ICSA certified FortiGate UTM, IPS, and firewall engines can inspect all the wireless traffic before they are routed to the LAN or to the internet. For example, the UTM policy can prevent an infected PC from propagating malware on the wireless network, or prevent users from sending spam while they're connected to a hotel hotspot. Fortinet wireless solutions support the latest WPA2 or 802.11i authentication and encryption standards, as well as the legacy WPA and web encryption. For guest access, we have a customizable captive portal login page with the ability to customize it with your logo and your disclaimer text, ensuring that users agree before they're given access to the wireless network. We also have two-factor authentication enabled on captive portal, which further secures employee login while they're connected to the wireless network. For scalability, we provide several features. The first one is the automatic radio resource provisioning, which provides ability for each access point to pick the optimum channel to ensure that there is no interference with other access points that are neighboring. This allows for very large installations. For instance, campus-wide installations can be done in this fashion. We also have a profile-based central management, which allows IT to create a profile for the optimum AP configuration and distribute that across all of the access points that he may have in the enterprise. So with this approach, a single change to the profile propagates to all the APs within about 30 seconds. We also have traffic shaping, which allows fair usage of the wireless bandwidth. And this becomes very important in the enterprise traffic, where a lot of users may be on the same wireless access point, but they may not be all doing business-critical tasks. This is a critical feature for enterprise class networks to allow them to scale and provide business continuity across all of the wireless network. For centralized control, FortiManager provides centralized configuration of all the FortiGates, which in turn configure all of the access points. And for log aggregation, the FortiAnalyzer can collect all the information from the access points and generate reports across the entire wireless infrastructure. In this section, I want to give you an overview of the FortiPlanner. The FortiPlanner is a custom-built tool for wireless pre-planning for the FortiAP family of products. I'd like to show you how to use the FortiPlanner on a sample floor plan. I'm going to open a sample project, which is a floor plan that has been partially completed, and we're going to go through this, the workflow of setting the scale of a floor plan. So we're going to go to the floor planning tool and set the scale, and this tells the tool what are the propagation parameters that it needs to calculate through to be able to provide the coverage map. So we're going to set the scale in this map. We also can draw the different obstacles by adding in structures. So the tool allows you to add walls that are, for instance, cubicle, doors, etc. So by going in and basically selecting the Add Structure tool, you can draw different obstructions onto your floor plan to tell the tool the signal attenuation that will occur when the wireless signal passes through these structures. The next thing that we need to do is to tell the tool what are the zones that we want these APs to be placed in. So the FortiPlanner offers 3 choices of zones. Normal is a zone that you would want to place APs. exclusion is an area that you don't want APs to be placed in. So for instance, in this model, we have elevator shafts and stairways that we don't want APs to be placed in. We also don't want it to be covered necessarily, since since in the stairways and such, in this model, we don't care much about the wireless signal levels. We also have an area called limited, and this is actually a very unique to our tool. In this case, we have selected our patio area as a limited zone, and this tells the tool to provide wireless coverage in this area, but don't put any APs outside. And this basically pushes the APs more closer to the wall, so the area outside can receive wireless signal. So once we set the zones, the next piece is to tell the tool what are the parameters that we are trying to optimize for. So there are pre-built performance parameters for normal coverage, voice over IP, or high quality data. And these different canned configurations allow you to set the different sensitivity levels. So for instance, in this case, we can say ensure or optimize for a client that has a sensitivity of -80 and a transmit power of 12. This is also very unique to our tool, where you can tell the tool the TX power of a client and the sensitivity of it, so that both aspects are taken into account when the formulas are applied. In this model, I'm going to select the 40AP220B, and I'm going to optimize, for instance, for 2.4 gigahertz frequency, and the orientation of my AP is horizontal, so that means it's flat against the ceiling. So I'm going to press OK, and I'm going to press the Place Access Points button. So in this phase, it's going to calculate the access point placement, and then we're going to go to the Analysis tab to see the coverage of these access points. So we can see that it has placed access points near the walls here to provide coverage for the patio. And you can grab the access point and move it around, and the plan will update. You could also drop additional access points to provide coverage in certain areas. But essentially, we can see that in this particular installation, we have the whole floor plan covered fairly well. You can also generate reports out of this tool to provide you a shopping list for our 40 APs. To become familiar with the 40 gate management system and the wireless controller interface, we provided an Internet accessible management interface under the URL of www.40gate.com. You can log into this interface with the username of demo, password of 40gate, and after login, you will see the management interface of the 40gate 310B, and on the bottom left-hand side, you'll see the wireless controller, where you can set different parameters and become familiar with this management interface. If you have any questions, please use the Ask the Question button, and for additional information, visit us at fortinet.com/wireless.